Hello everyone. We, the Purple team of IT 641 Distributed Database Processing, is here to present about our group project, which is analysis of vendor data and getting the results. So the main goal of this project was to analyze the vendor data and select which vendor is best for the store. So initially we had a big ERD of a store, warehouse or inventory like that. So we had the customer data, employee data, and we had product, orders and vendors. So our main task was to decide which vendor we need to select based on their performance in the store when compared to different other vendors in the store. So our team comprises of 5 members, and let me take a moment to introduce ourselves. So it's Sai Lakshmi, Prasanna, Sneha, Manju and myself Arun. So coming to the main introduction, what is the project about? So the big inventory database, we have to find out how the vendor performed based on their different categories which we have selected, and rate the vendor and make a decision on the vendor. So this involved a lot of querying, like inserting data like for maybe 20 years, and then we had to distribute the data and bring in QlikView to analyze the data and bring in big data and Hadoop, which was one of the best things which we learned from the project. And by doing all this, even though we were not successful entirely, but we were able to understand the basic concepts of each and everything, and we are sure to learn more from this experience and use it in the future. So the main benefit and gains for the marketing people in the stores or the store management itself is like you can get an idea how each vendor is performing and let them give a chance if they perform little bit bad, so that you will improve upon your sales, since each vendor will distribute the items more frequently than usual and there won't be any late deliveries and stuff. And also it will increase the profit of the store. So this is the main benefit and gain for in consideration to a store perspective. When we consider from our end, we were able to develop a fuzzy logic which can be reused in many different stores. Not only the inventory store or anywhere else we can use it, and it can be sold in a high margin. So why this project? The main purpose of this project was, till now there was no way on establishing how can a store owner select a vendor or not. So this project helps them a lot to decide on the vendor and thus make the store more profitable. And the process involved was initially a lot of data analyzing. Then we had to distribute because of the huge amount of data present by using distributed query processing. And then we used QlikView as an advanced tool to analyze the data visually and make it appealing to the clients out in front of us. And the last thing which we used was a big data concept, which we'll explain later in the future slides. So we divided the project into several sprints and scrums. Basically, we were following an agile methodology, which is one of the most modern technologies or methods used by different or a lot of software companies to achieve higher goals. So what does agile methodology means? It is like dividing the project into smaller modules, and the team will be concentrating on completing each sprint, which is a module, and it will be like in a shorter span of time, maybe like 2 to 3 weeks. And almost every day we will have a scrum meeting, and then we will update on the progress. And at the end of each sprint, we'll try to achieve the goal which was set up before the sprint, like we'll try to achieve the plan. And if it doesn't get succeeded completely, we will take the small portion to the next sprint and continue with the second sprint. So it is more of a faster approach, and clients will be we will show the demo to the clients after every sprint, so they can give any updates at any time they want, which has helped us a lot in improving the project considerably from the phase 1. So the sprint 1 was mainly about the analysis of the existing data of the store and improving, like getting more data like the recent years. Like initially there was data of like maybe some years, like 4 or 5. We'll talk about it in a more broader way in the coming slides. But it was like we analyzed the data model and analyzed the data and verified the data so that we could process the data more. And the next sprint was mostly about creating new tables in the databases and inserting data and bringing everything together, and then again verifying the information which we got. And the next step was to create the distributed query processing. So as given by the professor, we started analyzing some of the queries and how to distribute it, and then we ended up on starting the fuzzy logic for vendor analysis, and we had a lot of discussion during that time too, how to implement it, and the implementation was done in the next week. And sprint 4, we implemented the fuzzy logic. We created all the triangle and trapezoidal decisions, which we'll explain later. And also we had the decisions for every vendor based on the data they have provided from the store. So that was mostly in the sprint 4. And in sprint 5, we went for the distributed database. So we had to use different databases to store the data, which makes the process more faster and easier to process. And then we started doing ClickView to give the clients with a visual analysis of their data. And also we installed Hadoop to process the data a bit faster and to see how the performance comparison goes when compared with both the fields, like different databases and big data. Now let's watch the explanation and demo of the entire project and how we were able to accomplish the task given, and what all were the problems faced, how much we achieved, and how much we will try to achieve in the future stages. Handing over to next person, Sai, to explain about the ERDs and the initial data creation.
Hello everyone, this is Sai Lakshmi. As Arun mentioned the basic details of our project, now let me explain you about our data model. This is the initial global data model provided by the professor. So in this we play the vendor role. So we created a local data model by deciding some of the tables. You can have a look here, which is in like purple color. So we all got like these tables: back order, product, vendor price, vendor, prod vendor, return product, and return category. So basically product is product table consists of like the brand, class, product description, etc. the details, the basic details of the product in this table. And coming to the vendor, vendor consists of like the vendor details, his or her details, like name, street, city, etc. and all. Coming to the vendor price is mostly like how much the product is going to be cost by the particular vendor, and you can see the details consist of like vendor number, product number, vendor price, discount, start date and end date. And going to the product vendor, product vendor is like mostly it is related to the product vendor and the order given. Like when a product is ordered by a specific store, the time taken to deliver the product is basically the product vendor consists of that. And you can see the details: vendor number, product number, order date, etc. and all. Coming to the return category, so what are the products are going to be returned by the particular vendor or etc. That consists of like return category. And return product is mostly like what are the products are going to be returned to the vendor by the limitations placed by the vendor and all. So coming to the next step, we created a local data model by communicating with other groups and confirming the model whether it is correct or wrong. And the next process we done like insertion and creating the values in the table. The only condition we had was like we need to increase 20% for every year, and we faced some issues over there. We need to create more insertion values and in order line and vendor due to prod vendor and product. Finally, we just resolved all our issues and we came with a successful database.
So now we will be explaining about the fuzzy logic used in our system. So what exactly is meant by fuzzy logic? We are giving a set of ranges for determining the attributes or determining the category, that whether a vendor selected is good, bad or average. So, and that too we are giving multiple ranges so that we won't be prejudiced or like we won't be judgmental, maybe because like one time it can be of different values because of the maybe any external conditions. So we'll give different ranges, and that flexibility makes a fuzzy logic one of the best way to determine whether a vendor is good or bad. So I'll be explaining here about what are the fuzzy categories and attributes we had and how we achieved, like what were the conditions we did and how was the script formulated and what was made of the fuzzy decisions and rest of the stuff. So after a lot of brainstorming and discussions with the professor and the groups, we decided to follow have the following fuzzy logic, like following attributes and categories. So the fuzzy attributes which we selected were the time taken for delivery and the different return conditions offered by each vendor and the discount also offered. So based on these three attributes, we are determining whether each of the vendor is average, bad or good. And we gave for each of the attributes and for the specific category we gave a range by which we determine the good, bad and average. So for time of delivery, if it's good, it means like the time taken to delivery is like 2 or more days before the expected date of delivery. And if it is 2 or more days late, it is bad. And if it's between that period, we take it as average. And the return condition is like, if the return condition is within like 6 months or in a year, it's good. If it is like taking 2 months or like cash in return or within 3 months, return with refund in gift card, it's average. And if it's like within 1 month we should return, or like with 80% refund or within a week, we take it as bad. And the discount offered by vendors we categorize by based on their, like if it's 0 to 4% it is bad, if it's 4 to 7% it's average, and if it is 7 to 10% it is good. So based on the fuzzy data, like we had both fuzzy parametric triangle and fuzzy parametric trapezoid. So fuzzy parametric triangle, like it will be having like 2 ranges, and it will be like in a triangle, like we put 3 membership values for each triangle, while trapezoidal will have 4 different values. So it is to determine, like to give the flexibility to the vendors to be selected as a good, bad or average vendor. And so thus we have like 12 different like combinations of rule sets and rule mem sets. So a vendor like can be in between these 12 like decisions. And so like we made the following decisions, like for example, if it's good, like if the 3 attributes are good, then we give, like we can select the vendor. If one of them is bad, we like use a vendor conditionally, like, or one, if it's average, want the vendor. So similarly we made a lot of decisions. So in the first set, like we had almost 19 decisions and rest were like no decisions. And from 19 we made a smaller set so that to get a more clear-cut idea, like or on how to determine the vendor decision. So the first rule set had like almost 19 and the compressed rule set had 14 of the decisions. And then we made a net weight table. So in that we had like every year, like how did the vendor perform in based on like what was the time taken, what the discount offered, and what was the return condition by vendor for each product and for each year. So in this table it contains all this information which help us to determine the fuzzy decision. So similarly, like we then created all the fuzzy time, fuzzy return category and all the fuzzy tables, and we had a lot of procedures and functions running at the same time to determine what was the time taken and whether it should be bad or good or average. So this is a big procedure and functions script running. So, and we had triggers like if a new record is inserted, it will get updated, and procedures to put the vendor in the right set, where if it is like whether it's good, bad or average. We are explaining more about this in the report, since like the presentation is having a time limit, we can't explain each and every step. So you can see like there are a lot of procedures and triggers involved, and then there is a return condition. So till now it was like all of the time taken and then the return condition. Similarly, there will be one for discount as well, and then there is a final decision table like called vendor fuzzy decision. In that table, it is comparing each of the performance, like how the attributes got rated, and we will mix this one with the fuzzy decision table to make a specific decision for each vendor, and that is stored in the vendor fuzzy decision table, which is the final table of fuzzy decision, making all the decisions needed by the store.
Hi, this is Manju. I'm gonna explain about ClickView. ClickView is the most flexible business intelligence platform for turning data into knowledge. More than 24,000 organizations worldwide have enabled their users to easily consolidate, search, and visually analyze all their data for unprecedented business insight using ClickView simplicity. Effective decision making is based on having the right information available and easy accessible. Taking just minutes to learn, the automatic associations of ClickView create endless possibilities for making ad hoc queries without requiring tediously defined structures and hierarchies, as it is typically in other data analytics tools. ClickView promotes unrestricted analysis of application data, helping users make time-saving and accurate decisions. It brings a whole new level of analysis, insight, and value to existing data stores with user interfaces that are clean, simple, and straightforward. We can load data from different databases. So coming to our project, we took different tables from different databases. For example, we took return prod, WT_net, and backorder tables from Oracle, and order line and prod vendor from SQL Server, and product vendor and vendor price from MySQL. These have been done to the database connectivity. And right now, moving on to so after successfully loading the data, every ClickView document is made of at least one worksheet called main. We can also add more sheets. Actually, sheets help us display multiple data formats like multiple charts or multiple tables. First, let me start with the table box. We can create a table box based on, say, table, and based on table columns, we can select columns which we require. So here I have created table boxes for backorder, which consist of backorder number, backorder date, and backorder quantity, and so on, and also WT_net table and vendor table. So I'm going to perform few methods or operations on these tables. First, I added a multi-box object which lists all the values from multiple fields as a drop-down values. The selection of a value in multi-box highlights the related values in other sheet objects. For example, when I select products related to Amazon devices, it displays the products which are related to the Amazon devices, which is clearly reflected in other tables like vendor and WT_net and backorder. and also we have created uh, a text object which is used to show some descriptive information about the ClickView report being displayed. For example, we have created a text box which counts the total number of back orders from backorder table. So this is the count of number of back orders from a backorder table. Similarly, we have created a pivot table. This coming to the pivot table, it displays the maximum discount for each product. For example, this product number 110 consists of discount 7 and 7.36. So the maximum discount would be 7.36. Similarly, we have created one more pivot table for backorder quantity. Moving on to the graphs. We can also create pie charts or bar charts in ClickView. Coming to the bar charts are very widely used charting method to study the relationship between two dimensions in the form of bars. So here we took product category and product description. So it displays the total number of products or in a particular product category. For example, if I need to check like Amazon device consists of Amazon Echo Black Advanced, Echo White, which are displayed over here. And moving on to the pie chart. In pie chart also we are gonna display different products of each category, each and every category. If I click on the category product sports and outdoors, it displays me the one more chart which consists of products comes under sports and outdoors like in motion elliptical. Count of that in motion elliptical is like 3, so it displays the quantity number of each and every product. And at last we have implemented the search, bookmark and slider object. So first we have created two tables like product and return prod through text object. And for example, I'm gonna search products like based on brand or back order or something. So right now I'm gonna search for stamina. It displays the brand data based on the stamina. Right now we are having only 2 ellipticals, but I can search based on back order number. And also we have an option to add bookmarks. Just we need to click on the add bookmark button and information which we need to make note of there. And when we click OK, it displays a bookmark over here. After that, we have slider and calendar object which displays the products of a particular year. For example, if I want to display the products belongs to 2016, when I move the slider over there, it displays me the products related to the 2016 year. So this is all about ClickView.
Everyone, I'm Prasanna and today I'm going to talk about big data and Hadoop. Before going to Hadoop, let's just talk about big data. Big data is a collection of data sets which are large, complex and which are difficult to process through the existing traditional methods like using SQL, SQL Server or MySQL. Usually big data is defined with 3 different ways: volume, velocity and variety. Volume is the size of the data, how large the data is. Velocity is the speed and frequency at which the data is increasing every day. And variety is how many different types the data is, like is it structured, unstructured or semi-structured. Now, coming to Hadoop. Hadoop is a framework that allows for the distributed processing of large data sets across the cluster of commodity computers using a simple programming model. It also allows parallel processing. Coming to Hadoop installation, I have the link in my document for Hadoop installation where you can go ahead and install Hadoop. Here are few steps from where I install. This is the way I install my Hadoop. First install VirtualBox, and after that continue with the Hadoop installation steps as I have it here. And next, coming to the next point, the next thing is creating a file on the desktop and moving the file to the browser, moving the file to the HDFS name. How do we do this? First, just create a folder on your desktop. Create an empty folder and create a folder on the desktop. For example, you can see demo here. This is the file I created to transfer it to the HDFS. And now go to terminal, open terminal, and using the command hdfs dfs put, give the path of the demo you have it here and the file name. When you click on OK, the command is again executed and this file will be transferred to the HDFS. Let me show you where the file gets transferred. HDFS, browse the file system, user, and go to Cloudera. Here you will have see the demo. Demo. Here you will find the data which you have in the folder on the desktop. Here you see. This is how we transfer the data which is on the desktop to HDFS. And the next task is counting the number of word occurring in a text. For example, see the sample data I have here. Distributed process, normal process, and traditional process. I have distributed once, normal once, traditional once, and process 3 times. Let us run a word count program and see if we get the correct result or not. To run a word count, the command you use is Hadoop jar Hadoop. I have produced example jar word count. Sample is the document name here, and output is the output name which I am saving it. So when I execute this, you'll find the output again. HDFS name node container user, and look at this output. In this is output as we already know: distributed ones, normal ones, processed thrice, and traditional ones. This is how we get the word count of a particular document. And what's the next question of our? The next thing is the 4 different functions. Here I have a screenshot. The next question is create SP and SP tables. To create these SP tables, we have to go to terminal, and as it is similar to SQL code, but we have few changes here. In HQL, that is high query language, we have 2 different types of tables. One is external table and the other one is managed table. Managed table are the tables which already exist in the Cloudera, and which, even though if you want to delete the data from the cloud from these managed tables, you will never be able to delete them. It will be there. Coming to the external table, external tables are the tables which are real-time use tables. This is the command for the creation of tables. Create external table, gives the table name and columns as we kept in SQL. And here, in this case, I am loading the data for this particular table from the text file which is stored in my desktop. So, row format delimited. In that text file, I have the records differentiated by comma and stored as a text file. Here, if you can see, I've created SP and SP. And to load the data from the text file, we initially have to have the data on our desktop. If you can see here, I have SP and SPP. So these data I have to load into my database, HDFS database. So using the command load data local in path and give the path of the text file which is on the desktop into the table in table name. Using this command, you can load the data from the desktop to the table. And I have already loaded the data. To just see the data in all SP and SP tables, we go to user, Cloudera, and again user root. Oh, sorry, this is a different one. I can show it in the screenshot too. See, when after loading the data, when I select start from S, I have all the data from S. So in this way, we can load the data from the text file. The next question we have is the functions using SQL. First function I took is turning into uppercase. Select uppercase of S name from S. Then it will return all the S name records, turning them into uppercase. And the next is reverse. Reversing a particular name. For example, select reverse Smith from S. This gives the reverse of the name. And the next is the sum function. It will give you the sum of all the records which is selected. For example, here I have selected status. It's the sum of status from S. It will give you total sum. And the next one is minimum, maximum. You'll find this select minimum, maximum, minimum of status from S. And we have many other different functions which you can see when you type scope and help. It will show you all the different commands available, and if you want to know all the different functions, you just have a function so that where you get all the different functions you have in this scope, so that you can just access all the functions. For example, let me show you. If you go to describe, function and extended, I think it's extended or extended, yeah, extended, and give the function name. Now we'll get, I'm sorry, there's some problem. Describe function. I'm going to go back. Oh, there is some issue with this, but if you can see in this screenshot, and when I have describe function extended sum, I'm sorry, the main mistake I've did here is I did not enter into Hive. When you enter into Hive and try the same thing, if you press on show functions, it will show you all the functions you have. These are the functions we have: sum, then, due date, and date. These are all the functions you want. And if you want description of these functions, as I've already shown you, just go to that function extended, give an extended keyword and give function, then you will find all the details about that function and how the usage about the function and everything. And coming back to our assignment, coming to the next question, that is the equal join and outer join. Here So the first one is the equal join. Select sname and from S table and from SP table I'm taking quantity, and I'm sorry, this is outer join. I'm giving an outer join and it displays me an output. And the next one is my equal join. If you can see here, selection of sname and quantity from SP table and S table, and it gives me the output. These are all the examples of this is just an introduction on how we use the Hadoop and Cloudera activities get used to this Cloudera. And the next thing is, I can show you. I just implemented my database using Scoop. I'm using Scoop. I connected Oracle to my database. Going to access Scoop, go to File System, go to go to File System. Let me show you here. Yeah. Go to Scoop and then open the terminal in Scoop. When you open the terminal in Scoop and give a command, if you can see here, this is my command, user bin scoop import connect JDBC Oracle. This is my IP address, local host IP address. This is my port number and this is my username, and this is my table from which I am getting the all these columns, order line, product number. When I execute this, it will fetch all the data from my Oracle and bring it to my Cloudera HDFS. If you want Cloudera with HDFS name, browse the file system and you go to Cloudera and user and root. This is the out. Let me just. If you can see here, this is the order line output is my output for this fetched data. So order line output, and this is my full data which I fetched from my Oracle to this. There are many number of records here. Usually in traditional method it took around 14 to 15 minutes to just run this data, but here it just took few seconds to fetch the data. So Hadoop. So this is so clear that big data Hadoop can execute the big data in seconds, which is not very fast in our traditional methods. And that's all about Hadoop. Thank you.